Today we're also going to be looking at this idea of solving each system with elimination. And you're going to know that this is the method to use when x and y are on the same side of the equation. We call that a form called standard form. And what I really like about this method is you can tell right away what you're going to be getting rid of. So when I see the negative 2y and the negative 2y, they're the same. I'm going to look at that and say those are really close to canceling out. If I were to subtract these two, it would cancel out. But then I have a bunch of signs and I can make a lot of mistakes. So the recommendation that I've made is if you were to take this bottom line and multiply it by -1, it would change all three of these signs and then the y's would be able to cancel out. So let's start this problem by changing all of the signs for one of the lines. My ultimate goal was to get opposite coefficients. That's what I'm trying to do. Opposite coefficients. A positive and a negative that is the same thing. Now I have a positive and a negative. A -2 and a +2 will cancel out. Now I can add these two lines together to see what's left over. So I know those are going to be gone, but notice -6 plus 1 is -5x. 4 plus -14 is -10. By doing that one simple step, I've already gotten to the point where I can get the answer for x. I use division because I want to keep the x there. I just want to split off the -5. Division will do that. And now I'm left with a negative over a negative as a positive. I'm left with an answer of 2. Compare that to what we were doing with substitution. With substitution, I would have had to move this over, divide by -2, move this over, divide by -2, start setting them equal to each other. It would have been a mess. There would have been a lot of steps to do. But here, I was able to create an opposite very quickly, and then I was one step away and I solved. Now, I do have to go back and find out what the answer for y is. I'm not quite done yet. But that part's not going to be too bad because I can call x by its name. X's name is 2, which means back up here in one of my original problems, I just have to call x by its name. Everything else in that equation stays like it is, except that I called x by its name. And now that these are both numbers, I can multiply them. Now it's just order of operations, undoing things. I did my multiplication. There's nothing else here to combine. So now I'm going to start moving constants around. I want to get rid of that 12. Now I have it equal to 16. I want to split this -2 off from the y, so I'm going to divide by -2. Again, I'm just doing this because I wanted to keep y on this side of the equation. I want y to be by itself. So division is going to split the -2 off and leave the y there. So I have -8 for a y value. My x value is 2. I'm done. I don't have to do anything else with that problem. Now, I really liked that problem because I could tell what to get rid of. You can't really tell what to get rid of in this one because I can't turn 6 into 7. There's no way to turn 5 into 8. So you would think, well, I'm stuck. Can't use this method. But the reality of the situation is you can multiply these lines by anything you want to create an opposite. And we know in math that if you have the same two numbers being multiplied, you get the same product. So I'm going to cross my coefficients. That's what we call this process, cross coefficients. So all I'm going to do is take this number and rewrite it on top. And I'm going to take the number from the top and rewrite it on the bottom. Now, I have one clear difference in this problem from the one I had over here, which is I have a pair of negatives sitting out front. But I need one of them to become positive. It doesn't matter which one, but one of them has to become positive. So I'm going to slip a negative sign onto one of these two numbers. It doesn't matter which one. I'm just trying to get a sign change so that I can have opposite coefficients like I want. So I took the front numbers and I flipped them, and then I changed the sign on one of them so I could have opposites. Now, you still have to do 6 multiplications. We're going to rely on our math abilities to do this. You could use a calculator. There's nothing wrong with using a calculator, but all 6 of these multiplications have to occur. This is 42. This is 48. Oh, that's a brutal one. Well, if I did 6 times 25, that would be 150. Plus I have an extra 6, so that would be 156. Again, you could just use a calculator if you're not pro on that kind of math. Here is 42x. That's what I wanted. The reason I chose these numbers was to force x to disappear. Unfortunately, I still have a y value out here, and I still have to do this number out here, which I think is 91. That's one of those classic looks like a prime number but isn't. So now I have my opposite set up. I can add these two lines together piece by piece. And I kind of call this the cash drawer approach. You know, you separate your 1s, your 5s, your 10s when you're counting money. Well, we're going to do the same thing. We're going to count all of our x's together. Cancels out. Then we're going to count all of our y's together. I have 13y. And then I'm going to count all of my number constants together. That is negative 65. And then I have to get rid of this 13, but again, I'm keeping the y, so division is going to separate the number from the letter. And I get my wonderful answer, clean integer value of negative 5. Now, there was more work there, but remember, this process is still faster than getting rid of the x term, dividing by 8, and having decimals in both places. Getting rid of this 6 and dividing by 5 would give me decimals in both places. This would be really hard to do if I were trying to do this with substitution. But in this elimination process, crossing the coefficients, getting a sign change, got me to the answer actually faster than substitution would have. Now we can finish the problem. I can call y by its name. Y's name is negative 5. So I'll go back into the top equation, we'll say. And I'm going to call y by its name. Boom, negative 5. Everything else in that equation stayed the same. I just copied everything except I called y by its name. Now it's an actual math I can do. Order of operations tells me to multiply here. So I get my negative 40. Now I've done all the simplifying I can do. It's time to get rid of the constant. Plus 40 will get it to the other side. It leaves me with negative 14. Oh, not negative. Leaves me with positive 14. And then I need to split the negative 7 off. I'm going to use division to separate the number from the letter. And I get x is negative 2. I have now solved the system of equations. And my work here is done.